Anybody else infected by the affected by the blood? Anybody else in this class? Those who are living in KL? Okay, let us start our session. We already got that one. Okay, today we will go into the how we can look at the change in the size. Okay, so look at the balloon. The balloon, right? The balloon has a certain thickness, right? When we give a pressure inside, what happen? What happen? Become enlarged, right? What about the thickness of the balloon? Is it maintain or become smaller?
Smaller.
Smaller, right? So the inner radius will become bigger, the outer radius will become bigger, but the change in the thickness will become less. The thickness will become less, right? The R1 will become bigger than the old R1. The R2 will become bigger than the old R2. But the thickness in R2 minus R1 will become less than the original one, right?
Yes.
That's the understanding. So let us try to calculate it. How do we calculate it? Okay, that's the purpose of our class today. R1 there and R2 there. Let's say R1 is 0.1, R2 is equal to 0.2 meter. After we give pressure, what happened? R1 will go to new point, right? There's a new R1. And then R2 will go to the new point there. This will be go to R2 new. Right? The original thickness is what? T old is equal to R2 minus R1 is equal to 0.1. Right?
Yes.
So we want to check what is R2 new and what is R1 new. And then we can get the new T new. The R2 new minus R1 new. So we have to find the position of R1, new R1 and new R2 first. That's how we can get the new. But we already anticipated this T new must be less than 0.1, right?
Yes.
This is the first anticipation. Cannot be bigger. Just look at the balloon. When we blow it, what happened? Become bigger and bigger, but the thickness become thinner. Okay? That's the idea. So let us do this calculation. This is the main fundamental to understand first. Okay? So how do we do that calculation? Yeah? Go back to basic. Yeah? This fundamental there. And then there is a basic. Look at this. Yeah? There's a basic there. When you pull that one, there's a P there. Pull the P there. Remember, this is solid, right? Pull P there. So we have an element there. Sigma X there. Sigma X there. Are you with me?
Yes, doctor.
Yeah, we go back to the basic that. And then from here, sigma divided by the strain, we got the modulus Young, right? This is also elongate. Elongate. The stress diagram, the strain diagram. So the strain is sigma x divided by the E by the modulus. So we also understand that what is sigma? Sigma is P over A. Is equal to P over A divided by E, right?
Yes.
These are the basic understanding that one. And then we also know that one, that delta there is equal to PL over AE, right? So we also know the strain is equal to delta over original length, right? This is delta over original length strain. Elongation here over the original length. So we put here, so we got back EX, okay? What do we have there? There and here, what do we have there? Delta is equal to PL over AE. So we go back to that equation back. Are you with me there?
Yes.
Okay. Now we want to look into the strain part. Yeah? Want to look into the strain part. So the strain is stress over modulus Young. Forget about the loading first. Strain is, we know the stress. When we know the stress divided by E, can you got the modulus Young? E not? Yes. When you got the E there, go back here. You got E there, time L. E time L, we got the elongation, right? We got the
Yes.
strain that time the original length, we got the elongation. Are you with me?
Yes.
We got the time the original length, we got the elongation. We go by this process first. Okay. That is only in X. Now, what about this one? Two cases. I got a sigma X. I also got a sigma Y. What happened? EX. Remember our solid? We have learned just the last chapter 1, right? What is the equation that relating to that? Sigma X divided by E minus mu sigma Y divided by E, correct?
Yes, correct.
And then we have a sigma Z there minus mu sigma Z divided by E, right?
Yes.
Okay, fine. Now, we look at that we look at the element here. Now, this is sigma L, sigma H. And then outside here is sigma R. Are you with me there?
Yes.
So, what is sigma R? So, ER is equal to what?
Sigma R over E.
divided by E minus mu
Sigma H
sigma
over E.
H divided by E, right?
Yes.
So the strain in R is negative because inside here is pressure inside. We have a pressure inside. P1, let's say the value is 50 megapascal. Outside is 0. So this is inside here, position 1. So sigma H got positive, right?
Yes, positive.
Yeah, it's positive. Sigma R is negative, right?
Yes.
Yeah. So let's say the value here is 50. So minus 50 divided by 200. Let's say the E is 200 megapascal. And the minus, let's say the Poisson ratio is 0.3. And sigma H positive. Let's say the value is positive 83. 83. I don't know how to do the calculation. 10 to the power of 6. This 10 to the power of 6 divided by 200. 10 to the power of 9. So what is the value? Negative and negative there, correct? So what is the
Yes.
value? The value must be negative there. Write down there. What is the value? Please do some calculation.
Negative 3.75 to the
Then-
power of negative 4.
So this is negative 375 10 to the power minus 6, right?
Yes.
375 negative micro. So that is strain there. Ah. So can we find the position of that one, the strain that one? So can we find the strain outside there also? Also can. Let's say the value here is sigma H. Let's say the value is 33.3 and sigma R is 0. So what is ER2? Sigma R minus E minus mu sigma H divided by E. Okay? Your sigma R. So for this case, we can put some more. Minus mu sigma L over E. Because sigma L, if it's open, 0. If it's closed, got value, positive, right?
Yes, A.
Okay. That's value A. So let's say this is open. So this is 0. So this is also minus sigma L over E 0. Let's say this is open. So for this case, this is sigma R here is 0. 0 over E outside. Remember this R2 is R1. And then minus 0.3 sigma H is 33. 10 to the power of 6 divided by 200. Small value there. What's the value there, please? This is minus 375. This is
Negative 4.95 to the power of negative 5.
negative 4.95. 4.95, 10, negative 5. So what do we have? Negative 49.5, 10 to the power of minus 6. Negative 49 and negative 375. Are you with me?
Yes.
Okay. Now, the strain here, remember that in the direction of R. So can we find this? Can we write this? What is the new R? R1 new is equal to strain times the original R1. Can we do this? This is minus 375 10 to the power minus 6 times the original one, 0.1 meter. That's the new R1. And R2 new is equal to E times R2. So this is minus 49.5 10 to the power minus 6 times 0.2. So this value is bigger, right, than this one. Sorry, this is not R1. This is delta, right?
Delta R1 new minus R1.
Not R1, the delta R1, right? Delta R1, delta R2, change in radius, right?
Yes, correct.
And then what is the new R1? R old plus delta R1. What is R2? R old plus delta R2, correct? That's the idea. Are you with me?
Yes.
So we can solve this one. But unfortunately, this is not valid. Why? You see this? See this? Your R here until here is air. You put a length there. This is air, this is solid. Your length from your R here times the original length, this strain is the metal, but your R is the air, not metal. Can you see that?
Yes.
If that is all metal there, we can use that R2 equal to L for the position of the one. But this one is not all metal. This is metal, this is not metal. So we cannot use in the direction of R. In the direction of R, here there is no metal. This is formula for metal. Stress divided by strain equal to modulus Young. That's formula for metal, right?
Yes.
But this is not metal. This is air. Are you with me?
Yes.
So we cannot use, the theory is correct, but we cannot use that formula because that is not metal. So what do we use? We use in the direction of hoop. We don't use in the direction of R. In the direction of hoop here is ukulele. Circumferential length, 2 pi R, pi D. Are you with me?
Yes.
So, we don't use R direction. We use what?
H
Circumferential.
direction.
We use H direction. So, from this length to this length, we call it circumferential length, right? Circumferential length, CL, for R1. R equal to 0.1. CL is equal to what? Pi D or 2 pi R, right?
Yes.
When we cut here, we got a length. This length here got this length, right? That is 2 pi R. Correct me? Are you with me?
Yes, yes.
That length here are all solid. Your R is not solid. But in the direction of H here, all solid. So the formula solid can be used. So the length from here to here is 2 pi R. Original length. Are you with me, guys?
Yes.
Okay. Original length we know. 2 pi R, R is 0.1. We got the value there. Outside, also we got also a new the old 2 pi R. What is, this is R1. Circumferential length at R is equal to 0.2, we got 2 pi R. So this value is what? Push calculator, 2 pi 0.1, and then this is 2 pi times 0.2. What's the value there? Please first put
For 0.1 is 0.628.
0.628
8.
meter. The other one?
1.25. 1.26
1.26 what?
meter. 1.257.
Okay. So we know the original length there in H direction. Now we are calculating the old length, the new length divided by minus the old length. We got the change in length, right?
Yes.
Are you with me, guys?
Yes.
Okay. So we got the idea first, and then put aside first. So the value there, what is that? The outside is 1.257 meter. The inside is 0.628 meter. So put it there first. And then we go to the element here. We go to the element here at the more than one. At that one. We go by that one. This is sigma H. This is sigma R. Are you with me? Are you with me?
Yes.
Now we want to find this E in that direction. Strain in the Y direction, not Y. H direction. So what is EH? This is all R equal to 1. Inside here. What is EH? Let's go to basic formula. What's that?
Sigma E. sigma H over E
Okay.
minus sigma R over mu sigma R over
Minus
E.
poison ratio. Sigma R over E. Let's say the system is open case, so sigma L is 0. So we have that. We have that. So my sigma H just now is what? Inside 83, right?
My sigma yes.
Sigma H.
Yes, 83.
83.3 10 to the power of 6. And then E is 200 10 to the power of 6. Sorry, power of 9. Minus poison ratio 0.3. And then your sigma R is minus 50. This is pressure 50. Minus 50 10 to the power of 6. And then minus over 200 10 to the power of 9. So what is the value E then? Must be positive. Minus and minus become positive.
4.915.
What's that again?
4.915.
4.915
to the power of
10
negative
to the
4.
power?
Negative 4.
Negative 4. So change that to micro. What do we have there?
491.5 micro.
Okay. So that is EH. Are you with me?
Yes.
Now, for the length of EH, I got this value, positive 491.5 10 to the power minus 6. We know the original length is what? 0.628. Can we go to change in length?
Yes, can.
What is the value? EH times the L, correct? Strain
Yes.
times the original length. We got the change in length, right? So what is the value there? 4.91 10 to the power minus 6 times 0.628. So that is change in length. What is the value there?
3.08 times 10 to the power of negative 4.
4. Yeah? So we can write 0.0308 10 to the power minus 3. So that is 0.0308 meter, right? A millimeter. Very small. Minus 3 millimeter, right? Everybody, are you following me?
Yes.
So we got a change in very small, the change in 0.03 millimeter. So what is the new length? What is the new length? L new. L old plus delta L, right? L old is what? This one. 0.628 meter plus 0.0308 meter. Sorry. Plus 0.010 to the power minus 3. So what's the
Doctor,
value?
I think it's 0.308, not 0.0308.
0.3, right?
0.3.
0.3. 0.3. So this is 0.3 minus 3. Still we have to change to meter, that one. This is meter, right?
Yes.
That is meter, right? So what is the value there? 6.
6283.
Correct. Are you with me?
Yes.
So 0.3 minus 3, there's 0.0003, right? 0.0003. So you add it up, you got this one, right?
Yes, doctor.
Yes. And then that is the, what is this?
L new.
L new. Can I find the R new?
Yes, can.
How? How? This must equal, this must equal to 2 pi R, right? Ukulele, 2 pi R must equal to this, right?
Yes.
Yes.
So, if I want to find the R new there, so just divide by 2 pi. Are you with me?
Yes.
So, my R new is what? R1 new. Who's calculator there? What's the value there?
0.1.
Long value.
0.099998.
Cannot be. Must be higher than 1. That's why you cannot put small error here. You have to put so many decimal places. Because R1 must be bigger, right?
Yes, should be bigger.
Must be bigger than 1. What is the value there? What is the value there, please?
I still got the same answer. 0.099998.
0.099998. So that means you cannot leave 0.628 like that. There must be 628 something there. Are you with me?
Okay.
The original line is what there? 2 pi R. You cannot write 628. 628 what? Fill it up all the way.
0.628318.
318.
53.
Come on.
53. 53.
53. 0.6283183. Right? Put it back there. 31853. And then plus this one. What do we have?
0.10049.
No. Here, put the value first.
0.62862653.
And then you got your R new. What is R new?
0.1000049.
How many zero?
30.
49. Some more?
019.
Okay. So that is in meter. So it's getting bigger, not? Yes, it's getting bigger, right?
Yes.
Okay, now, same procedure, we go to position 2. We go by the H direction to find the R. And then divide by 2R, 2 pi again, we got the R again. Same procedure again. Okay? Go back here. So what is the EH at R2? So sigma H outside is what? 33, right? Minus E is 200. Minus positive ratio. Your sigma R is 0. You have E. So what is the value there? What is the value there?
165 micro.
165, 10 to the power minus
6.
6. Positive, right?
Positive.
Okay. I write this one first. That value is R1 new is equal to 0.10004901 9 meter. Write that one first. This is going 2 now. So I write this one again. You have to go back slowly to understand the process. If not, you're memorizing formula and then gone. Okay, no one you. Go back. So you know this one H. So I want to find what? I want to find delta. So delta is strain time original length. You see that? That's how you work. You talk to yourself. So delta here, how much the elongation at that line here? Delta is equal to strain time the original line. So the strain is that one, right? 165 10 to the power of minus 6. The original line here is 2 pi r, right? Outside here. I got the value. Got the real value back again. Why the value? Not 0.257. There's a lot of point there. Why is that?
1 point.
No. 1 or 1.2, right? Okay?
1.256637061.
Okay. So that's meter. Times this one, you got the change in the length. What's the value there?
0.27. Wait. 2.07, sorry. 2.07 to the power of negative 4. More.
More.
3, 4, 5. 1151.
More.
1151
Ah,
to the power of negative 4.
10 to the power of negative
4.
4. And then there is change in length, right? What's the new length? L new. This length here. All the way length there. Circumferential or correlate. Circumferential length new. What is that? Old length plus delta, right? The old length is what again?
1.25
1.25637 plus delta 2.073451151 10 to the power minus 4. So what is the value there?
1.2568 44407.
Yeah? That's a
Triple
new
four.
length. Huh?
444.
444. Yeah. So R2 new. Sorry, this is not R. This is a circumferential length. So why is R2 new? That one divide by 2 pi. Are you with me, guys?
Yes.
2 pi r is equal that length. So the new r is divided by 2 pi. What is the value there?
0.200033. 0.00033.
0.20033.
That's all.
That's all.
That's all.
Okay? You got R2 new 0.200033. Are you with me there?
Yes.
Yeah. And now you minus it. What's the new thickness? R2 new minus R1 new. So what do you have there? 0.20033 minus 0.10004919. So what is the value there?
0.09998.
How many 9?
0.0.
0.0.
0.
0.0.
9998.
9998.
3981.
So this is less than 0.1, right?
Yes.
The original one is 0.1. How is that 0.1? Because 0.2 minus 0.1 is equal to 0.1. The original one is 0.2 minus 0.1, right?
Yes.
So this is less than 0.1. So makes sense not?
Makes sense.
That's how you do that calculation. Okay, are you with me?
Yes.
We do the calculation in calculating that using the circumferential length, not the arc length. Because the arc length, there's no solid there. Are you with me?
Yes.
We go by that line because all are solid. All are solid. That's why we use EH times the original length in H. This is 2 pi r. So we can get the change in elongation. We use delta r is equal to ER divided by times r. So that line here is not solid. You cannot use that formula. Are you with me, guys?
Yes, doctor.
This is very important. So that's why you have to understand what is stress-strain relationship and then the common sense. Common sense. Why this one cannot be used? Why this one can be used? The answer is, this R here is not solid. This H here is all solid. The formula is for solid. We take a long route, but can solve also the problem. Are you with me?
Yes.
The basic formula is what? The basic formula is just simple formula in solid one that you learn. What is that? We got a length there, L. We got a strain there. Original line. Full load become an elongation, right? So delta divided by L is equal to the strain, right? Strain in that direction. All are solid. It all start with this solid one to solve this one. Well, the strain here come from stress, right? X is equal to sigma X divided by E minus mu sigma Y divided by E minus mu sigma Z divided by E. So the strain come from stress in whatever direction that we have. You got. All come from basic understanding of solid. Okay. Okay, I think it's enough for today. I think you know how to calculate the change in the size. R1 changing, R2 changing. So the thickness also changing. So what is the changing? What is the new? What is the old? So you have to blend yourself to create those equations on your own. Oh, what is the original length? Original circumferential length of 2 pi r. What is the new circumferential? 2 pi r, the old one, divide plus change in that one, or the delta. You do it one step with another first, not jump to conclusion until the end. Remember, we made the error just now. We leave also many decimal places there. The answer is not correct, right?
Yes.
Because the change is very small. We're talking about metal here. Change very small. Cannot see by our eyes, but we can calculate it. Okay, I give you some exercise, but different pressure. You have to calculate that one by sigma H, sigma R, everything outside, inside, and do that one again. Okay, thank you very much. Assalamualaikum. Do the exercise first.
Thank you, doctor.
Thank you.
Thank you.